Okay, good day everyone. So this is actually a continuation of the topic that we had before, and this is on the election configuration. So in this lesson, we will try to learn more on the different nature of elements, as well as how do the electrons being distributed all throughout the different shells of the element. So in our discussion on the development of atoms, we have discussed that Newlands was actually the one who proposed that electrons were being distributed on a shell. And then later on, it was found out that electrons do travel in a shell or what we call the orbit. And then they are also distributed using the four distributions. Okay, o kaya they are distributed using the four shells. And these shells were later on called as the SPDF or what we call the electron configuration. Okay, SPDF, S stands for sharp, P stands for principal, T stands for diffuse, and F stands for fundamental. So these are the four shells of our elements. And then in the S shell, we have seven sublevels. That's why it's called 1s, 2s, 3s, 4s, 5s, 6s, 7s. And then if we're going to look at our electron configuration, you can just see that that is 2. The electron distribution there is 2. It means that in the S shell, it can only contain 2 electrons, okay? So less than 2 or equal to 2, but not more than the 2, okay? So in the P shell, we have less than or equal to 6. And then in the diffuse shell, we have less than or equal to 10. And then in the fundamental shell, we have less than or equal to 14. So those are our distribution of electrons. We also have here an image of the periodic table. So this image of the periodic table shows us that electrons or elements were actually classified according to families, which is we have also discussed that. And they are also classified according to groups. Groups are families and they are also classified according to periods. But when it comes to the classification according to the shells, you can just easily say that 1A, group 1A and 2A actually contains the S shell. That's why hydrogen, including the helium here, it's 1s. Okay? Lithium, beryllium, that's 2s already. Okay? We have sodium, magnesium, that's 3s. Potassium, calcium, 4s. Rubidium, strontium, that's 5s. Cesium, barium, that's 6s. And then francium, radium, that is 7s. So these are the different classifications or the different subshells of our group 1A and group 2A. Okay, so this is the alkali earth metals and then the alkaline metals. Okay, let's move on to the principal shell. We have here the boron to neon and then we have nihonium to oganesson. Okay, and this part actually gets or actually takes the P, okay, the principal shell, wherein this one starts, the sublevel starts from 2P, then we have 3P, and then after 3P we have 4P, then 5P, 6P, and then 7P. So these are our sublevels when it comes to the different sublevels on the P shell. Okay, after the P shell, we have the D shell. They start from scandium to zinc. We have, this is 3D, and then this one is 4D. Wait, wait for a moment. Okay, this one is 4D. I think my ink is not seen. And then this one is 5D. And then the last one is 6D. So we have four sublevels actually, or we have four subshells We have 3D, 4D, 5D, and then 6D. And then we also have here the F, the fundamental shell, wherein we have the 4F and then the 5F. Okay? So if we're going to, you take a screenshot of it so that you have your notes with you. Okay, so I'm going to clear my drawing. Hindi, wag na lang. Okay, so I have here an example. So if we're going to look at or predict the electron configuration of francium, you can just simply say that francium is here, right? So francium is here. If francium is here, therefore, what is the sublevel or subshell of francium? That is 7s. Okay. So if the subshell of francium is 7s, then therefore it's here on the first part. So 7s1 and then 7s2. Therefore, what is the electron configuration of francium? That is 7s1. Okay? Francium is 7s1. Okay, what about iridium? Iridium is the 77th element in the periodic table. If we're going to predict the location of iridium as well as the electron configuration of iridium, you can just simply say that 3D, 4D, 5D. Iridium is 5D, however, we're not yet done. So iridium is 5D, but we need to look at the amount of electron that is on the outer shell of iridium. So let's start from 57. So 5D1, 5D2, 5D3, 5D4, 5D5, 5D6, 5D7. So iridium class is located on the 5D7. It means that there are 7 elements on the outer shell of iridium. Okay, understood? Okay, 7 electrons rather on the outer shell of iridium. Okay, what about boron? Okay, boron is here on the 2p. The sublevel or the subshell of boron is 2p. Therefore, 2p, take note that p has 6 subshell of 6 electrons. So we have here 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Therefore, our 2p now is the 2p1. Boron is 2p1. Okay, is it understood? Or more examples? Okay, so more examples. So we also have here um, iron. Let's say iron. So iron is located in the 26 elements of the periodic table. So iron is located here, and the subshell of iron is 3D. 3D, so 3D1, 3D2, 3D3, 3D4, 3D5, 3D6. Therefore, iron is located in the 3D6 of your electron configuration. Okay, what about in the F? Okay, F shell po tayo. Let's have, um, let's say thorium. So we have here thorium. So this is 4F, this is 5F. Then therefore, thorium is located on 5F2. So thorium is located on 5F2 of your periodic table and the electron configuration of your elements. Okay? Okay? So now let us move on to the distribution of electrons in our periodic table. So we're going to distribute electrons using this electron configuration mnemonic device, wherein, in layman's term, it is also known as the Christmas tree of your periodic table. So just what we used to say a while back, we have here 1s to 7s. Okay, the sublevel of S shell is, or the subshell of S is 7. Okay, next the subshell of P is 6. That's why we start at 2, 3, 4, 5, 6, 7. And then the subshell of 3 of D is 4. We have 3D, 4D, 5D, 6D. And then the subshell of 4 of F is 4 and 5. Okay, so that is 2. Alright, so if we're going to look at again our periodic table, let's try to solve for iodine. Iodine is here the 53rd element in your periodic table. So by merely looking at iodine, you can just simply say that iodine is located in 2p, 3p, 4p, 5p. So 5p, 1, 2, 3, 4, 5, 6. Iodine is located in 5p5. Okay, so we have there 5p5. Now, let's try to look at iodine, okay, if it really is located in 5p5. Right? So we have there iodine. We need to write iodine as our 53rd element. Okay? So let's start from 1s. Okay, 1s. We have talked about the distribution of elements or electrons in our shells. Okay, so we have agreed that S, okay, has two. Okay, okay, maximum of 2 electrons. So, pwedeng maging 1s yan, 1s1, o kaya pwede rin maging 1s2. Depende po kung ilan ang hinahanap nating electron. But since we're looking for 53, then therefore, lagay natin lahat yan. After 1s2, kailangan pa natin ng 51 na element. That's why, let's continue. We have there 2s2. Okay, after 2s2, ilang elements pa yan? 49. After 2s2, we have 2p 6. Okay. 49 minus 6, that's 43. So, madami-dami pa. After 3s, okay, 3s, 2. 43 o 41 na lang. After 3s2, we have 3p, 6 ulit. Kasi 6 nga naman po ang maximum na electrons na kaya niyang i-contain. Okay, after 3p6, we have 4s2. After 4s2, we have 3d10. And then after 3d10, we have 4p6. And then we have 5s2. And then we have 4d10. And then after 4d10, we have 5p. And we have agreed a while back that iodine is located on 5p5. Now let's try to count if it's really located in 5p5. So we have there 2, 4, plus 6, that's 10, 12, 18, 20, 30, 36, 38, 48, and then plus 5, that's 53. Okay, is it the same? Iodine 53, is it the same? Alright, very good. So 53 here and then 53 here. So it is just the same. Okay, getting there. Alright, very good. Next, let's try um, potassium. So potassium is here, potassium 19. So potassium is the 19th element in your periodic table. So let's try this one. Okay, potassium 19. Let's try to write potassium. Potassium is the 19th element in your periodic table. Okay, so let's try to use 1s again. 1s2. And then we have 2s2. And then we have 2p6. Then we have 3s2. And then after 3s2, we have 3p6. Okay, let's try to count. Right, potassium is here. Let's try to count it now. So 2, 4, 6. So that's 10. And then plus 12 plus 6, 18. So we need one more, right? That's why we're now going to put 3s. Okay, sorry, 4s. So that's supposed to be 4s. So we're going to write 4s1. Okay, bakit isa lang po? It's because we're only needing 19 here. So we need to write 4s1. Okay, so that's 18 plus 1, 19. We're looking back. So it means 1s, 2s, 3s, 4s, 4s1, and then calcium will now be your 4s2. Okay, understood? Okay, so that's it for the long method of your periodic table or of your electron configuration. Okay, another example. Sige. Let's try the D naman. Since we're done with the P, we're done with the S, let's try with the D. Okay, let's try to go back to our periodic table. Okay, you can see bismuth. Okay, let's try to use bismuth 83. So we have there bismuth 83. Again, bismuth 83. So we have Bi 83. Right, what are we going to do here? Bi 83. We're going to use the long method. But if we're going to predict the location of bismuth, that is 2p, 3p, 4p, 5p, 6p3. So 6p1, 6p2, 6p3. So bismuth now will be located in 6p3. But let's try to solve it for us to look um, for us to look if our answer is correct or wrong, right? So we have there bismuth 83. Okay, so bismuth 83 again 1s2, 2s2, and then after 2s2 we have 2p6. Then after 2p6 we have 3s2. After 3s2 we have 3p6. And then after 3p6, we have 4s2. Very good. Oh, tignan niyo dito. And then after 4s2, we have 3d10. Okay. After 3d10, we have the so-called 4p6. Am I right? After 4p6, we have 5s2. And then after 5s2, we have 4d10. And then after 4d10, we have 5p. Okay, 5p6. After 5p6, we have 6s2. Then after 6s2, we have 4f14. And then again, 5d10. And then our last is 6p. We have told you a while back that bismuth is located in the 83rd element in the periodic table, so 6p3. Now let's try to look up. Okay, let's try to get the sum of this. We have 2, 4, 10, 12, 18, 20, plus 10, 30, 38, 40, 50. Okay, again, 2, 4, 10. Okay, so we have 20, 30, 48, 58, then 20, 30, 20, 30, 48. Okay, 48, 54, plus 2, 56, plus 14, 70, plus 10, 80, plus 3. Alright, very good. So do we get the same? Yes, we got 83. Okay, we got 83 in our um, periodic table configuration, okay? In our electron configuration. Alright, so moving on, I'm going to teach you the semi shortcut. So we're going now to use the noble gases as our basis of your electron configuration. So instead of putting all this 1s2, 2s2, 2p6, okay, instead of putting all of this, we're just going to use your reference, which is your noble gases. Okay? So wait, take a screenshot of it. 1, 2, 3. So we also have here your noble gases. We also have here your noble gases. When we say noble gases, it means that they can no longer, okay, they no longer need somebody for them to, um, they no longer need somebody or any other element for them to thrive. Okay. So we have neon, argon, krypton, xenon, radon, organism. These are our noble gases and they can be used as our reference in getting the electron configuration of these elements. Okay, let's try to use barium. Okay, barium as our example. Barium is the 56th element in your periodic table. So if we're going to look for the noble gases before barium, ibig sabihin you're going to look at the noble gas that has a lower atomic number rather than barium. So that is xenon. Okay, that is xenon. Right? So if we're going to use the xenon as our basis, we're going to use 2p, 6, 3p6, 4p6, 5p6. Okay, so we're going to use 5p6 as our example or our basis for barium. Okay, so we have here, okay, barium, that's 56, right? Okay, so if we're going to state it, you're just going to look at, okay, you're just going to state xenon. Since xenon is 5p6, then therefore barium, okay, what comes next after 5p6? Well, we have 6s. Then therefore barium, okay, 54 yan. Xenon 54. So 55, 56. And therefore we're going to put xenon 56. Alright, very good. Next po tayo. Okay, next. So sorry, sorry about it. Okay, we're going to look at our periodic table again. We're going to use or we're going to identify radon. Okay, radon as our basis. So here it is, radon. And let's locate thorium. Let's locate thorium. So here, thorium is here. Radon is here, the 86th element in your periodic table. And we're going to locate thorium now using radon as our reference. Alright? So we have radon, the 86th element. Let's put it here. Okay. So radon, so thorium muna. Sorry about it. Thorium. Let's use thorium. Thorium is the 90th element in your periodic table. So we have here, we're going to use radon. Radon is the 86th element. So we'll be needing two more, right? So we have here 2p, okay, 6p. Radon is 6p6. And then after radon, we have 7s2. So that will be 88. And then after 7s2, susunod 5f. That's why our thorium is located in the 5f2. Our thorium is located in the 5f2 of your electron configuration. Okay, so that's it. I hope you enjoyed this video. If you have questions, please comment down your questions, or you can directly email me at dianarose.flora@lorma.edu, or you may also message me in Messenger, Diana Flora. Okay, goodbye everyone, and I'll see you again on our next meeting. And I hope that you learned something, and then please read this one, please watch this one, because your exam will be based on periodic trends as well as in the electron configuration. Okay, goodbye everyone. I'll see you again next meeting.